Good morning, everyone. Thank you for joining us today. In our last deep dive, we talked all about the human side of the equation, skills, ethics, and the future of work. Well, today we're flipping the script and focusing squarely on the machine. But, and this is a big but, we're not talking about the robots you're used to seeing. We're going to be venturing out to the absolute bleeding edge to explore what the next generation of robotics really looks like.
For, the last 50 years, when we thought of a robot, we pictured that classic image, right? Rigid metal, steel and aluminum, all inspired by the human skeleton. And sure, they're powerful, they're precise, but they're also heavy, dangerous, and pretty clumsy. Well, that old model is being thrown out the window. Researchers are now looking at a completely different blueprint, the natural world. We're talking about a future that's less about steel skeletons and more about the incredible ingenuity of the octopus, the collective power of ant colonies, and even living tissue itself.
And that brings us to our first major frontier, soft robotics. You see, the limitations of those old, rigid robots really forced engineers to get creative. How do you make a robot that's safe to work alongside? How do you make one that can handle something delicate without crushing it? The answer? It turns out, was right in front of us, in the boneless, squishy wonders of the animal kingdom.
Okay, so let's really get into this. This isn't just a minor upgrade, it's a total paradigm shift away from traditional mechatronics. So what is the secret sauce here? What's the foundational idea that makes this whole new class of machines even possible?
The answer is a concept called biomimicry. And it's such a powerful idea, right? Why reinvent the wheel when nature has already spent literally billions of years on research and development? So instead of milling a chunk of aluminum, we're diving into material science to cook up new polymers that are soft, flexible, and can bend and twist in all sorts of ways, just like living tissue.
And the absolute poster child for this whole idea has to be the octopus. I mean, think about it. With 8 arms that can bend and twist anywhere, it has what we call infinite degrees of freedom. Its physical form is just so incredibly effective that it leads to this brilliant, mind-bending concept called embodied intelligence. And this idea completely changes how we think about a robot's brain.
Embodied intelligence. It's like a genius shortcut. It means the robot's physical body, its shape, its softness, does a lot of the thinking all by itself. So for instance, a soft gripper doesn't need a complex AI to calculate exactly how hard to squeeze a raspberry. Its own inherent softness naturally applies the perfect amount of gentle pressure. The intelligence isn't just in the code, it's literally built into the material. The body's doing the computational heavy lifting.
So you might be asking, all right, if there are no motors and no gears, how on earth do these things move? Well, the most common method is something called fluidic actuation, and it's just beautifully elegant. It's almost like a high-tech balloon animal. You pump fluid, usually just air, into these specially designed little chambers inside a silicone body. As the chambers inflate, the whole structure bends or stretches. By simply controlling the airflow, you get this huge, lifelike range of motion. No servos, no gears, just air.
And this incredible design just blows the doors open for applications where old-school robots just can't compete. I mean, they're naturally soft, so they're safe for people to work right next to them. That gentle touch makes them perfect for handling delicate foods, like berries or fish. In medicine, we're talking about gentler surgical tools, rehabilitation gloves that help patients recover. And for exploration, imagine a robot that can just squish itself under a door or through a crack in a collapsed building. It's a total game changer.
Okay, so we've looked at the intelligence built into a single soft body. But what happens when you take inspiration from another aspect of nature, the incredible power of the group? That brings us to our next frontier, swarm robotics.
You know, the traditional way of thinking in robotics is what we call monolithic. You build one giant, super complex, and super expensive robot to do a job. But that's a high-stakes bet, because it creates a single point of failure. If that one robot breaks, the whole mission is a bust. Swarm robotics just completely flips that model on its head. It asks a much more interesting question. What if instead of one big smart robot, you had 1,000 tiny simple ones?
And the philosophy is to trade that one complex machine for hundreds, maybe thousands of simple ones. The intelligence of the system isn't programmed into any single unit, it's an emergent property. The whole becomes way smarter than the sum of its parts. And how does this magic work? Well, it all boils down to 3 key ideas. First, it's decentralized, no boss, no leader. That makes the whole swarm incredibly robust. Second, the individual bots are cheap and simple, so it's super easy to scale up. And third, they only communicate with their immediate neighbors, which is ridiculously efficient.
But that's the big question, right? If there's no leader yelling out orders, how do they possibly coordinate on a big, complicated task? The answer is this absolutely fascinating biological trick called stigmergy. It's basically indirect communication. Think about an ant leaving a pheromone trail to a food source. It's changing its environment, and that change acts as a signal to all the other ants. Well, roboticists are now creating digital pheromones, leaving virtual breadcrumbs in a shared digital space that allows swarms to coordinate incredibly complex tasks, like mapping a disaster area, all without a single central brain. It's brilliant.
All right, if you thought that was cool, you need to buckle up. We're about to go even further down the rabbit hole. We've gone from mimicking individuals and mimicking collectives to our third and most futuristic frontier, where we stop just copying biology and we start integrating it. This is biohybrid automation, where the line between a living thing and a machine gets completely erased.
And this research leads us to this incredible, and let's be honest, kind of unsettling concept of biobots. It sounds like something straight out of science fiction. So what in the world are these things?
So here's how it works. Researchers take a tiny, flexible 3D printed skeleton. Then they grow living muscle cells, say part cells that are sensitive to light, directly onto that skeleton. Then, when you shine a light on it, the cells all contract together, causing the little biobot to swim. But that sink in for a second. The muscle tissue is the motor. It is a machine, literally powered by living cells.
Okay, so beyond the pure technological wow factor, this obviously opens up a huge can of worms, ethically speaking. The second you put living and maybe one day sentient tissue inside a machine, you're in totally uncharted territory. It forces us to ask some really profound questions. Where do we draw the line? What's the moral status of a machine like this? At what point does a tool become a creature?
So we've looked at soft robots, swarm robots, and biobots. And you might be thinking these are three totally separate paths. But in reality, they are all contributing pieces to a single, massive, overarching goal for the entire field of robotics. They're all part of the quest for the Holy Grail, true, long-term autonomy.
The ultimate dream here is to build a machine that you can send to, say, Mars or the bottom of the ocean, and just let it work for weeks, months, even years, with zero human help. The softness gives it adaptability, the swarm gives it robustness, and the biohybrids hint at a future of self-powering and self-healing. And of course, no company has captured the public's imagination on this quest more than Boston Dynamics. Their work is a masterclass in learning from animal movement.
And you can really see their approach in their two most famous robots. Think of Atlas, the humanoid, as the Olympic gymnast. It's a pure research machine designed to do one thing: master dynamic balance in real time, just like an athlete. Then you have Spot, the dog-like robot. Spot is the hardworking field technician. It takes all that research in mobility and puts it into a package that can actually go out and do a job, like autonomously navigating a factory floor to inspect equipment. But as amazing as those viral videos of Atlas doing backflips are, we're not quite living in the robot future just yet. There are still some massive hurdles on the path to true autonomy. For one, energy. Batteries are the Achilles heel of mobile robotics. They just don't last long enough. Then there's the AI itself. It's powerful, but it's brittle. It's book smart, not street smart. It struggles when it sees something completely new. And finally, self-repair. What happens when a robot breaks down on Mars? Right now, the answer is game over.
So what's the big takeaway from all of this? The crucial point is that the future of robotics isn't just about making stronger, faster versions of the same rigid metal machines. The entire field is undergoing a fundamental shift towards systems that are adaptive, that are collective, and that are deeply, deeply inspired by the elegance of the biological world.
And what that really means is that building the next robot is no longer a job just for mechanical engineers. It's this grand interdisciplinary challenge. You need material scientists inventing new polymers, AI researchers building smarter brains, and biologists uncovering nature's secrets, all of them working together to solve this puzzle.
And if you want to see what a world run by these kinds of incredible autonomous systems might actually look like, well, you're not going to want to miss our next deep dive, where we'll explore the autonomous planet, a vision for the future.
Thank you so much for listening. Be sure to subscribe to our channel, Tech, AI, and Beyond, for more explainers on the amazing technology that is shaping our world.